exactly write the rule. So how will you write the rule here? F of x plus g of x. So before you do any other, I want you to write the rule. So memorize the rules. Like we talked about before, memorizing rules, it's going to help you to, what? It's going to help you to develop your memorization skills. And that's what you are here, that's what you are in college for. Develop your part of it is to develop your memorization skills. Okay? So by doing this, you are not wasting your time. That's your grill. That's what you're supposed to do. So first write this. Now let's do this. F plus g with respect to x is equal to, pick the f of x function. This means f of x. Very easy. Plus g of x function, x squared minus 4. Now we combine like terms. What do you get?
3x squared minus 3x minus 3.
So this is the final answer. F plus g of x.
What about r of x?
So this problem, that's why we are not picking r of x, because the question is not asking about r of x. If we had g, f plus r, then you're going to pick r instead of g. Okay? Number 2. Sorry? I'm sorry? Question?
Wouldn't like factor out that first?
No, because this is adding like terms. Why we are factoring? Adding like terms. This is adding, basic adding polynomials. Okay?
So we're not trying to find x? No.
No, we are not.
This is not an equation to solve for x.
I mean, that's something.
This is not an equation. We are just adding algebraic expressions. We have two algebraic expressions. We are adding combined like terms, and that's like pre-algebra. Pre-algebra and way beginning algebra, the first chapter. Basically pre-algebra. Okay? Alright. Know the difference between equation and an expression. Expression we only simplify here. If it's an equation, yes, then we solve. For something we are supposed to just simplify, we don't say solve. You guys follow that? When you say simplify, you only simplify. Like in chapter 1, we only did the simplification stuff. Chapter 2, we did solving some stuff. Chapter 1, we did some solving equations also. Okay? Okay, so. Okay, number 2, part B for the same thing. F minus r of x. Fine. So we are given these three functions, we need to find this. You know what to do exactly, right? So what do you do here? This is equal to, first we are going to write the rule. Don't do without writing the rule. Must write the rule. So what's the rule? F of x minus r of x. Now we have to be careful. What is f of x? 2x squared minus 3x plus 1 minus r of x. X squared plus 5x plus 6. If I write like this, is this correct? No, because it's more, we are subtracting more than one term. What do you need to do? You need to put parentheses. So you need to write your parentheses. Now you guys know how to simplify this whole expression. We need to get rid of parentheses first. So we do 2x squared minus 3x plus 1 minus x squared minus 5x minus 6. Combine like terms, class.
X squared minus 8.
X squared minus 8x
Minus 5.
So this is f minus r of x. Good? All right. Okay. example part C, example number 1, part C. So we do example number 1, part C. F times G of X. China, what do you do?
The f of x times g.
F of X times G of X. F of X times G of X. Very good. Okay, write F of X. 2x squared minus 3x plus 1 times G of X is x squared minus 4. Can we leave it like this? No, we know how to multiply to one polynomial and a binomial. Even trinomial times trinomial, we know how to multiply. So what do you do here? Again, this is pre-algebra. You take, it's better if you start with this one first. Maybe I would like write this. Can I erase this part? So here I'm going to write f times g of x is equal to, I'm going to put the binomial part first so it's easier for me to multiply. Is that okay, class? So now I'm going to take this, multiply, distribute, file it, right? This times this, and then we have to do this, multiply this, and this, and this. 6 multiplication and then combine like terms. So what do you get here? Let's do this real fast. 2x to the 4 minus 3x cubed plus x squared minus 8x squared plus 12x minus 4. So if you leave it like this, that's not simplified all the way. Now we combine like terms. Minus 3x cubed minus 7x squared plus 12x minus 4. That's it. So f times g of x is equal to this. Final answer. Okay, so the next example number part D. Example number part D. What's f of x? F f over g of x. You divide g of x. So now we have to be careful here. So we write the rule again. We need to find this. So we write the rule. F over g of x is equal to 2x squared. What's my f of x?
2x squared minus 3x.
Minus 3x plus 1 over
X squared minus 4.
x squared minus 4. First write this. Now we know we cannot, something like this, before we divide, we need to give the restrictions. We have talked about restrictions in chapter 1. We have talked about restrictions in chapter 2, big time, right? So we need to give restrictions. Before we give restrictions, what do you do here? What do you need to do before we give restriction here?
Factor it out.
We need to factor. To give restrictions, we need to factor. So what are the factors of this?
X minus 2, X plus 2.
X plus 2, very good. So now you state the restrictions. So it's the restrictions. What's the restriction? X cannot be equal to 2 and x cannot be equal to Then each of these factor cannot equal to 0, and then you solve for x. Okay? Okay, so the next part is, you need to simplify now. Okay? So first take the restrictions and see whether we can simplify. Can we factor the numerator there?
Yeah.
Yes.
No.
Even if we factor, we cannot cancel
No,
x.
that's true.
Okay? So I would do so in this case you can do the what?
Quadratic.
Long division. You need to do the long division. You guys familiar with long division? Okay? So in here you need to show the long division. Or later on I think we are going to do synthetic division. But for now, do the long division. Okay? So long division, you're familiar with synthetic division also, right? Because you have taken intermediate algebra. Okay? So let's do the long division. So we get 2x squared minus 3x plus 1 divided by x squared minus 4. How many I can write here? I need to get rid of this, correct? Right? So what can I write? I get rid of this term, I need to write 2. So just multiply this times this now. So we get 2x squared minus 8. Subtract. So this is negative. Negative become, when you subtract two terms, this is negative, negative become positive. If it's positive, it becomes negative. So these are the signs we are going to consider now. So when we subtract, these get cancelled. So we get negative 3x plus 8. Now this is degree, higher degree than the remainder. So we cannot write something here because the remainder is lower degree, 1 degree less than the divisor. Okay?
Can you explain again why it's plus 8?
Okay, when you do the long division, we are supposed to subtract. Like if you, let's say you had 171 divided by 5, what do you do? How many
5.
goes to 70? 3, 50, and then we subtract, right? When you do now you subtract this 2 to this, you get 2 remain, and then you bring 1 this one.
Subtracting negatively. It's not that.
Yeah, yeah.
Oh, okay.
So here when you subtract, subtracting more than one term, so this becomes subtraction, this subtraction become addition. Okay? Subtraction is part of doing the long division. That's how we do the long division. So we need to subtract always. Whatever we write here, you multiply with this. Like whatever we write here, you multiply with this and write down, and then you subtract. Okay? So this is in long division, you guys have learned this. This is the higher degree, this is degree 1. What's the degree here in this expression? Degree 2. So if this is degree, the degree of the remainder is less than the degree of the, what is this called? Divisor. When the degree of the remainder is less than degree of the divisor, we can't continue division furthermore. If this is 2, if this is x and this is x, we can still write a 3 here. Okay? You guys know that. So look at long division problems. This is again beginning algebra. So what do I get here? Just 2 only. 2 is the quotient and this is the remainder. That's all. We stop here. So the final answer to this, you write 2 plus negative 3x plus 8, so over x squared minus 4. That's it. Okay? This is the remainder. We write that. If we, like here, how many 5s goes to? This is 4, 20, remainder is 1. So now I'm going to write this. I'm going to say 175 divided by 5 is equal to whatever your quotient plus the remainder is out of the divisor, right? We write like this. Same thing, you simplify and write like that, okay? You do the long division. This is the quotient is 2. You write the quotient separate. Remainder here and what? Divisor here. Same thing like we did here. Okay, guys?
Do we add the restrictions to the answer?
Yeah, but this, yeah, restrictions we already, yes. This is the answer with the restrictions.
What happens to the one?
What happened to what?
The one?
1?
Yeah, where it says 2x squared minus 3x plus 1.
Oh, I'm sorry, you are right. Oh my goodness, I'm sorry, I didn't see that one. So this is what? Positive 8. You need to bring this one. Thank you so much. Sorry about that, guys, because I saw this. So this, after that you need to bring this one. So bring the 1 here. So this is what? Now. So the final answer is you add this, negative 3x plus 9. Thank you so much. So this is negative 3x plus 9. We had to, whatever the remaining you have to bring down. Okay? Okay, guys, thanks about that. Okay. All right. So I'm not going to do another example, but on the test I'm going to let you guys do something like this where you're doing the long division. We don't have a lot of time to do. I've been reviewing most of your beginning algebra stuff last 7-8 weeks, a lot. But right now I don't have time to, because we have to cover a lot of new stuff, okay? So I'm just saying, similar test question. Except something with restrictions and something that you need to do what? Long division. Okay? Okay, so this is easy and this problem should not take test question, this whole problem. Okay guys, so let's do composition now. This also I'm going to go through real fast. Rule. I'm not going to explain this in detail, but I will just give you the rule and explain to you how to just use the rule, okay? So what this means is this, rule number 1 is F composition with G. Composition, we put a small 0 here. This is not multiplication, this is not O, this is means when you have two functions, what this means is what? Composition. Is equal to f of g of x. Like that. This means this. Rule number 2. You guys have seen this, correct?
Yes.
No? You have not seen this? F composition. Anybody who has seen this before? You have seen it? Okay, good. This rule number 2 is F G composition of F is G of okay. So these two rules know how to write. Now, So I had to write this. This is on page, these two rules are in page 231. So read this. For this rule, we are going to say the domain of F composition G, the domain of F composition G of X, the domain of F composition G of X is the set of all X in the, is the set of all X in the domain of G, domain of G, such that G of X is the, such that G of X is the domain of F. Okay? So let me explain this. So I will do an example for this. Let example number 1 here. Let f of x is equal to 3x minus 4 and g of x is equal to x squared. Okay? Question number 1, find f composition g. This is of x. Sometimes they put parentheses, sometimes you will see like this also. So if it comes with parentheses, this means the same thing. Okay? Questions, guys? Okay, so what does this mean? What do you need to do first now, Sarah?
You put the g of x, kind of do this, where you put the g of x inside of the f.
Yes, so
function?
all we have to say is use the rule. Learn how to use the rule. So everybody need to know how to write the rule here. You try to do other stuff without writing the rule, I'm not going to look at it. You need to show the rule first, okay? So everything like we did before. We learned how to use 4 rules before. Now this is the 5th rule, 5th and the 6th. And the composition, I'm going to write as 1, 2. Okay, I wrote as 1, 2. So how will you write? F is at the beginning. Then we are going to write F of parentheses. Of means always with a parenthesis. Instead of x, we have what? G of x. G of x is the domain for f, you see. This is the rule. Now we are going to follow. We are going to follow with the f function. First we need to write f function. F evaluated at what? What does this mean is function f evaluated at function g. That's what it means. Function f. Remember you guys said f evaluated at -2. This means f evaluated at -2. Now f evaluated at what? G of x. It's the same thing. So how will you write this? Write the f function first. 3. So I'm going to put, wherever x, I'm going to put like within a parenthesis. I don't know what I'm going to substitute for g. Okay? -4. I know I have to have g of x. What is my g of x here? G of x is, this is the g of x has to go in inside here. G of x is equal to x squared. Okay? So I need to put x squared here. Everybody understand this? Now simplify this.
3x squared.
Now if I ask you to do, or the homework you have, f composition g of -2, you already have what is f composition g is, this rule. This is the function for f composition g. Now what you need to do here is what?
Plug -2 into F.
Put -2 here, because this is the f composition g function. Put -2 here, whole thing squared. X is -2, this is x squared minus 4. So we get positive 4, 12 minus 4 is 8. Everybody understand? So it's not a big deal, right, to find the composition of a function. All you have to do is apply the rule and know what this means is f evaluated at g of x. Okay? Okay, so we were talking about the domain. If you ask the domain of this function, what does this rule say? The domain of f composition g of x is the set of all x in the domain of g, because such that g of x is the domain of f of x. So what's the domain of g here?
-infinity to positive infinity.
We know, we have talked about domain of, we have seen now, you guys, you already know to find domain of lot of functions. We are very good at it. Okay? So whatever the domain of different functions, you find that. And here we need to look at domain of g of x. What's the when you give this function, I will ask also the domain. So the part A is, this is one part, and then this is another part, and then I'll say find the domain of f composition g. So what's the domain of f composition g here? We know only look at the g of x. G of x is x squared. What's the domain of x squared? Negative infinity to positive infinity. We have seen this many times, right, class? Now certain things you're expert. The second you see it, you know what it is. There's nothing to think now, right? Okay. So domain of, that's it. Part, example number 1, let's do another example. Example number 2, let r of x is equal to x squared plus 5x plus 6 and t of x is equal to x plus 2. Okay? I'm going to ask find T composition R of x. Okay? T composition R of x. What do I need to do? You start with T. This means T of R of x. Like that, like that. Easy. So now the next step is we work with T. T function is this. T function is x plus 2. Instead of x, my R of x goes here. So R of x is the x here. Which is what? x squared plus 5x.
Plus 2.
So what is this equal to?
X squared plus 5ac.
So this is T composition R of x. That's all you need to do. Very easy. If you ask to evaluate like x equal to -2 or -1, you can do it, right?
I thought it was supposed to be x squared plus 5x plus 8.
Yeah.
Oh, excuse me. You guys are good. All right. So, what else I need to find here? The domain of this function, right? So, domain of this function is domain of T of x, R of x. No,
R of X.
domain of R of x, sorry, R of x. Okay, domain of R of x. You need to get this domain. So what's the domain of R of x here? So the domain of T composition R x is equal to domain of R of x. We know to do that by using the rule. We are given two functions, we don't care what's the domain of this in here, we need to get the domain of this only. Domain of this is the domain of the whole function. Okay? So what is it? We know that's a parabola, that's what we are going to do in chapter 3, graph parabola. We have talked about graphing parabola. I gave you the 4 rule of graphing parabola, 4 steps of graphing parabola, right? This is the basic equation of parabola. If I have this y is equal to what? X squared plus 5x plus 6, and I ask you to graph this is y or f of x, right? You guys know how we graph this, right? Find the x-intercept, y-intercept, axis of symmetry, what else? Vertex. Remember those four things that you guys use to graph parabolas like this? Everybody has to know that's a question on the test. This test is way harder, not harder if you know the material, it's actually easier, but since it's going to have, exactly know what you are going to have. And example, practice those examples. I'm going to give one of these problems. It's a review problem. We have covered this long time ago at the beginning of first week or the second week of semester. We covered this, okay? So now we know this is a parabola going upward, okay? So this is a parabola going upward. We don't have to know the graph. What's the domain of this? Domain of this is all real numbers, right? You see parabola going upward like this. The domain of this is all real numbers here. So we know the domain of this is what? Negative infinity to positive infinity. Okay? Okay guys, so sometimes you will have rational function for R of x. Then you need to give the domain of R of x as using those restrictions and take the restriction away and then write the domain in terms of what? Interval notation. You guys did exam problems on the test. Okay. Okay. So that's basically it. Now basically what this says here is, so if I write the rule here, G composition F, then I need to write the domain of G composition F is the domain of F. It's the same thing. Okay? So what this means is this. So you have, let's say you have function F. You can also write under this rule this diagram. Then so there is something going from here, a rule. This rule is called F. That's the F rule. Remember we did an arrow diagram using, right? So if I use f rule is, let me use the f of x. So I'm going to use f of x is equal to, let's say 2x minus 3. So this is f of x rule. Okay? So what's domain of f of x? What's the domain of this rule? What's the domain of this rule? Negative. Any straight line domain is negative infinity to. So we know domain of this is negative infinity to positive infinity. So I can pick any number on the number line. I can use the domain for that f to be that domain. Right? Okay. Now I'm going to have something from here to here called g of x. I'm using a different rule. Different rule. There are two rules in this whole, I'm going to use this one rule and another rule here. So this rule g of x, I'm going to use g of x to be, let's say g of x is equal to g of x is equal to x squared. Okay? So, now, look what happening. Pick a number. Pick a number. 1. Okay? So any number I'm going to pick from domain, this domain, I'm going to pick 1, I'm going to pick negative 3, I'm going to pick negative 5 or 7, any number. What will happen, what is f of x means? This will become what? F of x evaluated at 1. F of 1. What is f of 1 going to be? So f of negative 3, what is this? Is f of negative 3. Okay? What is f of negative 3 here? Negative 9. So now f of negative 3 is negative 9. This is using the f rule. See that? Now what is the domain of this? What is this? Is g of x. G of x is using, g of x is using negative 9. G of x taking this, everything here is f of whatever the domain. Okay? So g is using this one. So g is using f of, this is g of what is x here? F of x. You see that? Okay? So what do I get from here to here? G composition F. This is G composition F. Okay? You can see that? So what's happening here is this. So now, if I put now negative 8 to G of x, what do I get? This is negative 9 in G of x. What do I get? 81? So this will give you 81. In other words, if you have this, in this, if you have this, you take negative 3 will map to what at the end?
81.
81, very good. Negative 3 will go to what? 81. So are we going through the middleman? That's what the composition is, avoiding the middle person. And get a rule without the middle person to go to the third person. You guys understand that? That's what composition means. So in the book, if you don't understand this diagram, it's okay. I was not even going to give it to you guys today, but I thought this will give you a better understanding. Okay? So now we can do, now if I do example, I'm just going to do Let's do for this problem G composition F of -3. How will I do this algebraically? I need to write the rule first. So what is this means? G of f of x. First do this. Show the work for this one first. G function is x squared, like this. There's nothing here. That's all the G function. Focus on writing your steps correctly, exactly. That is what we have to train ourselves. G function with what? Evaluated at what? G function is just x squared, correct? Evaluated at what? F of x. So write f of x inside. 2x minus 3. Now simplify this. 4x squared minus 12x plus Are we done?
No.
No.
We still need to get G composition F of
-3.
-3. Now what do you need to do?
One -3 is that.
-3. Guys, please, can you please show all the work and follow all the rules just like you're doing the example. Simplify this. 4 times 9 minus minus plus 4 times 9 is
36.
huh?
36.
Equals anyone.
You see that? Do we have to go through the middleman like that?
No.
No.
No, it's just here.
So you understand what composition means, right?
Yes, yes.
So now if you have this diagram, instead of that I'm going to have this diagram. It's the same thing. I'm going to write, this is F rule, this is G rule. So when you see diagrams like this, you understand what this means, okay? It's using a rule, it's an arrow diagram using that rule, a map. Okay, I don't want you guys to just see numbers only, I want you to see the story behind, exactly what those notations mean. F means by itself, this means a function rule. It's not just letter F. Now you know it's a function rule. It has a sign, a rule. A sign rule, right? Okay, so now I want to write this. I want to go from here. Sorry guys, sorry. So I want to write, we did a rule from I want to put here F composition, I want to put F composition G. What do I do now? How would my rules be? So this is G of x, this is F of, so this is, the G of rule is here, right? Right? So this is going to take the, so these are the x's here, so this is going to be G of x here, or G of x's here. So here, G of what? This is the rule F here. So I'm using G of x, the domain here. The domain is g of x.
So it's going to be
F
f of g of x.
of g of x. See that? This means f of g of x. All the g of x's are here. You see why domain is g of x here? Remember? I'm showing it to you in diagram. So now what is this? F of g of x. You see why it's f of g of x. See? So we go take the domain here and we apply this rule. This is a rule, this is a function rule. The domain of this rule is whatever the g of x is in here. Okay? Questions, class? Everybody understand? So using the rule. Okay. So okay, one more thing. Now we are going to talk about one-to-one functions, but before that, okay, 2.7. I need to finish this today, guys. 2.7 and even go into the next section. Okay. So, how many problems with the composition? At least 2. So we have, I said there's going to be 3 exam questions. So after I did today's, the next part, there's 3. This is about at least 15% of your test. Okay? Okay. So, question? Huh? Okay, guys. So let's go through 2.7. Chapter 2.7. What is chapter 2.7? Inverse functions, right? Inverse functions. So let's write the definition for this. The book has, the definition that the book has is okay. So let me write the definition that the book has here, that's okay. This is easy, once you see the example, you will see this is very easy, okay? But at the beginning, definition is, I'm going to write a lot of words here, but if you can't follow it, it's okay, I'll explain it to you later, okay? Let f and g be 2 functions. Everybody understand what this means, right? Functions means they are rules, they are functions. F of g of x is equal to x for every if f of g of x is equal to x for every domain of g, we get x and g of f of x also equal to x for every x in the domain of what?
F.
Domain of f. Very good. So if this is the case, if these two rules are applying, then we can say under this condition, the function g is the inverse of function what? Function f. If we have these two conditions, we are going to say function g is the inverse of function f, and function f is the inverse of function g. Okay? I'm going to explain this to you guys in a little better way to understand what is the inverse. You'll see it in a minute. Okay? So right now the book says to use this definition. Okay? And the domain of f must be the domain of f inverse. Now instead of f inverse, inverse of f, we write like this. This notation. This notation means what? Inverse of, this is not a negative 1 power, this means inverse of f. So what is inverse of g? This is the notation. Inverse of g, how will you write this? Same thing. Okay? Okay, so now example number 1. Okay, so we'll do I'm going to do an easy one first. Find the inverse of f of x. Finding the inverse of a function. Now, right now we are going to do how to find the inverse. I'm kind of trying to rush this, I have 10 minutes. Inverse of a given function. So this is a test question big time. So f of x is given, I'll start with the easy one, 5x minus 3. Find the inverse of this. Okay? Okay, so the first step, the book has steps, I think, to find the inverse of function. The book has steps. Find it. It's on page 242. Steps for this is page 242. How to find inverse of function? Steps are in page 242. So please read the steps, I'm just going to follow it. Okay? So here, what you need to do, first step is, this is what? Y value, right? So I'm going to write y is equal to 5x minus 3. We need to find the inverse of this function. Inverse means, the other way to look at inverse is you replace y value, y numbers with x numbers with y numbers. That's the inverse. That's all. Okay? So if I replace, what do I have to replace this y number? What do I have to replace it by? X. So we are going to replace this with x. X is equal to 5. Replace x by what? Y. That means we are looking for minus 3. Now we need to find the inverse function. Whenever we have to find the function, are we going to give in terms of x, the function rule? We are going to give the function rule in terms of what? Y. So the next step is from here, solve for?
Y.
Solve for y. That's step 3. Solve for y. First write the rule in terms of y, switch x to y, and then solve for y. Very easy, guys. These rules are in the book. So now what? Solve for y, what do you get? 5y is equal to negative x, negative 3, divide both sides by 5. What do I get here? Y is equal to negative x over 5 minus 3.
Shouldn't it be negative?
Yeah. Should be. Why didn't you just move the 3 over and just put x plus 3? Because I'm just saying, because you wrote 5y equals negative x minus 3. That doesn't make sense.
Okay, I think I made a mistake here. I'm solving for 5y, negative x.
Could you just add 3 over it? Or no?
No, you're supposed to minus 5y from each side.
Yeah, then
And
it's
you
minus
divide by
5y,
negative,
right?
then it's positive.
Yeah, I had to take this as minus 5y, sorry. Okay? I could have done like 5y and add x plus 3 also, correct?
Why is x negative now? I'm confused.
Could be a different
Yeah, I mean, I could have like kept the 5y here, move the 3 to this side and wrote x plus 3.
Okay.
5y is equal to x plus 3, okay?
Okay.
So isolate the y part, okay? Y term.
Okay.
So you isolate the y term and solve for y. So this is divided by, so now y is equal to x over 5 plus 3 over 5. Okay? Divide by negative 5 both. Okay. Now we are not going to write this as y. That's f, this is the f function. We need to find the inverse. So we are going to say this is the f inverse. That's all. So how to find the f inverse? You need to follow these 4 steps or 5 steps. It's in the book. Okay? So now, and I can say graph this. Graph f and f inverse on the same coordinate plane. So let's do real fast, graph these 2 functions. So we have 2 functions, correct? So we are going to graph these 2 functions on the coordinate plane. I'm going to rush this, guys. So when you graph this, first one, 5x minus 3. So I can go to the negative 3, slope 5, go up 5, over 1, go up 5, over 1. We know this, right? So this is how we graph this line. Okay. Now let's graph this one. 3/5. 3/5. What's the x-intercept of this? 3/5. And what's the x-intercept? When x is equal to 0, when the y value is 0, what is x going to be? What's the x-intercept here? Find the x-intercept and y-intercept. What's the y-intercept?
0.
3/5. Y-intercept is 3/5. So 3/5 is here, y-intercept is 3/5.
It's a little over 1.
Okay, y-intercept is 3/5. What's the x-intercept?
1/5.
When this is 0, solve for this, is -3. So this is the x-intercept. So I'm going to graph this line by using the y-intercept and x-intercept. This is how we graph this line. This is the second line. This is f inverse of x. This is what? F of x. Now look guys. What is this line here that goes through the center? What is this line that goes through the center? What is the equation of this line? This is y is equal to x line. On this line, x and y are the same. On this line, any point on this line, x value and the y value are the same. So now, the function and the what? Inverse, they are mirror image of each other. What's the mirror going to be? What's the mirror? Y is equal to x line. See, if you take this part, this is the mirror image of this, and this is the mirror image of this. Okay? If you take this part, this is the mirror image of this is the mirror image of this. Each one is the inverse of each other. Each one, F inverse is the inverse of this is the inverse of that. Each one is the inverse of each other. So what is inverse means? Now if you pick this number, take this point, what's the coordinate here? 0, -3. What's the coordinate here? -3, 0. Do you see how the coordinates are changing?
Yeah.
So whenever we see the inverse, do you see? So not only you know graphically how the inverse of each other work, their coordinates are
Inverted.
inverted, change. So here, what's the coordinate here? This is 3, this is 0 and 3/5. 3/5. What's the coordinate here? 3/5 and 0. See? So all the points works like that. Does it make sense? Okay guys, so now one more thing. We can check here. Now we'll see whether we can do the rule here. Okay? So this is big question on the test. You're supposed to graph. I'm going to ask you to graph. Sometimes the graph can be like this. Okay? And then you're going to get a graph like this because this is this. Okay? So you are not only going to graph straight line, you're also going to graph right curves, right? Now what do you need to check here? Use the definition and check whether these are inverse of each other. You need to calculate F composition G and G composition F. We need to work with these two. So I will ask you to show graphically, algebraically. This is just graphically you're doing. Okay? Now in order to, after I get the rules, I need to show this. So what is my G of X? What did I get for G of X? What's the rule for G of X? y is equal to, g of x is equal to x over 5 plus 3/5, correct?
Yep.
What is f of x?
5x minus 3.
5
X minus 3.
x minus. So these are my two functions. I need to calculate this and this. So let's calculate this real fast. What do I get? I need to work with f function 5 times x minus 3. Instead of x, what do I have to write here?
X over 5 plus 3 over 5.
Oh, I didn't write the rule here, guys. Sorry. I'm going to write this. F composition g of x. Am I right? So I need to work with f. 5x is, what do I put for x here?
X over 5
plus 3 over
X over 5.
plus 3 over 5
Oh, this is plus, yeah. Plus 3 over 5.
minus 3.
Minus 3.
Minus 3 here, I have it here. Okay? Minus 3 here. Okay, so what do I get? 5 is the common denominator. 5 times x plus 3 over 5, I can write like this. Minus 3, I cancel this to this.
X.
So I get,
X.
5 get cancelled. So I get x plus 3 minus 3, I get x. So this is good. I got what I'm supposed to get, right? The rule is supposed to give me a x. Now if you do the same thing for, I need to not just, this is not good enough. You need to also check the other way. See, the rule says to check for both, right? Given these conditions, see, there are two things that you need to check. Are you guys following this class? So always it boils down to the definition, the rule. So if you just do this and you got this, it's not enough. You need to do the other way. So what's the other way? So this we check. What's the next part? So this is the checking part. What's the next one we are going to check, class?
Decomposite.
No, what's the rule?
G of f
G
of
of
x.
x.
What do I write?
G
G
of
of
x.
But before that, in terms of composition,
G of x composition f(x).
isn't F composition G?
No.
Oh, yeah. G composition. Oh, sorry, I thought I picked it. So we did this, right? So the next one is G composition F with an X. You check whether this is also all the way to X. You can do this, okay? This check whether this is all the way to X. And if this is good, then you know. And then we already saw graphically, we are having what? Please wait, don't go yet. We are having what? We can do graphically. We can also change the x coordinates to y coordinate to x, and also get the set of ordered pairs of the inverse function. Some at least some point, right? You change x's and y, x into y into x. We can also graph both functions, and we can see both functions are mirror image of each other with respect. Every time it's mirror image, you need to say, what is your mirror? What's your mirror? It's symmetric with respect to y is equal to x line. We discussed symmetric with respect to x-axis when we did the transformation. Also we discussed symmetric with respect to y-axis, when the y-axis is the mirror, right? We discussed symmetric with respect. Now we are discussing symmetric with respect to what? Y is equal to, this is the line, y is equal to x line goes at the center. Okay, so here when it's, these two functions are mirror image of each other with respect to y is equal to x line, that means those two functions are what? Inverse of each other. So when it's inverse of each other, the composition of each other is algebraically, when you do the algebra, composition supposed to get what? Supposed to be
Domain of x.
x for all x in the domain. All x in the domain of G and domain of F. Everybody understand?
Yes.
Okay, so very good. You guys did really good. Good class.